Hello students. In my last video, we were discussing about Euler method to solve the ordinary differential equation. So in this video, we will discuss about the modified Euler method to solve the ordinary differential equation. So let me make it clear. In case of Euler method, to find out the solution of ordinary differential equation, it was one approximation solution or approximated solution. Whenever there is an approximation, there is an error. We all know it. Whenever there is any approximation, there might be some error. So similarly, in case of Euler method, there was some error. In case of modified Euler method, whatever we are going to discuss today, we will try to reduce that error. Only we can reduce the error. We cannot make it zero, but we can reduce that error. So let us discuss the modified Euler method. So before going to discuss about modified Euler method, let me make you remind about the previous Euler method, where yn plus 1 was yn plus h into f of xn yn. This was the formula for Euler method. Okay. So now, in modified Euler method, we will first get the approximation by using the previous Euler method. Okay. So we will use the Euler method, means the previous normal Euler method, to get the first approximation. And let us denote it as y of n plus 1 star. Okay. So what was the previous Euler method? Yn plus 1 star will be yn plus h into f of xn yn. The previous Euler method, this was. Now we will improve the approximation by taking the average of f of xn yn and f of xn plus 1 yn plus 1 star. So now we will improve the approximation by taking the average of f of xn and yn and f of xn yn plus 1 star. Okay. So now, in case of modified Euler method, the improved approximation, that is called yn plus 1, will be yn plus h into the average of f of xn yn and f of xn plus 1 yn plus 1 star, like f of xn yn plus f of xn plus 1 yn plus 1 star, the average, so divided by 2. Let me write it once more. Yn plus 1 equal to yn plus, let us divide 2 by h by 2 into f of xn yn plus f of x n plus 1 yn plus 1. Okay, this is the formula for modified Euler method. Okay, this is the formula for modified Euler method. Okay, let us do or solve a problem. Let us solve the same previous problem. Solve dy by dx equal to y minus x, y of 0 initial value, y of 0 equal to 1 by 2, h equal to 0.1. Let's. Okay. So now the answer. Here h is given as 0.1. F of xy is y minus x, and x0 is equal to 0, y0 equal to 1 by 2. Okay. So as per our previous discussion, the first approximation yn plus 1 star will be yn plus h into f of xn yn. I have already said yn plus 1 will equal to yn plus 1 star equal to yn plus h of f of xn, h into f of xn yn. Okay, so yn plus 1 star equal to yn plus h into f of xn yn. Okay, so according to the previous Euler formula. Okay, now according to the improved Euler formula or modified Euler formula, yn plus 1, simple yn plus 1 is equal to yn plus h by 2, see the formula in the box, h by 2 into f of xn yn plus f of xn plus 1 yn plus 1 star. Okay, now h by 2 into here f of xy equal to y minus x, so f of xn yn will be yn minus xn plus f of xn plus 1 yn plus 1 star will be yn plus 1 star minus f of xn plus 1. Okay, so now yn plus 1 will be yn plus h is equal to 0.1 by 2 into yn minus xn plus yn plus 1 star. It is already calculated in the previous section, that is yn plus h means 0.1 into f of xn yn means yn minus xn minus xn plus 1. Okay, see it carefully, yn plus 1 star will be yn plus h of f of xn yn. It is already written here. Okay, so minus xn plus 1. So this will be yn plus 1 will be equal to yn plus 0.1 by 2 means 0.05. So this calculation yn here yn, so it will be 2.1 yn minus 1.1 xn minus xn plus 1. This is the key for this problem only. This is the key for this problem. Just a minute. This is the key for this problem. So now, putting n equal to 0, we will have y1 equal to y0 plus 0.05 into 2.1 y0 minus 1.1 x0 minus x1. We know x0 is equal to 0, x1 equal to x0 plus h. In my previous discussion, I have already said h is the common difference or common gap in between x0, x1, x1, x2, x2, x3, x3, x4 similarly. So x1 will be x0 plus h, that means 0 plus 0.1 means 0.1, simply 0.1. So now it will be y0 will be 1 by 2 plus 0.5, 2.1 into y0 will be 1 by 2 minus 1.1, x0 will be simply 0 minus x1 means 0.1. So now as per calculation it will be 0.5475. Similarly, when n equal to 1, y2 will be y1 plus 0.05, 2.1 y1 minus 1.1 x1 minus x2. So y1 is already calculated, 0.5475, x1 is already known, 0.1, x2 will be x1 plus h, 0.1 plus 0.1, that means 0.2, so it will be 0.589485. and so on. In this way, we can go on calculating. Okay, let me solve a next problem. dy by dx equal to x square plus y of 0 is equal to 1, h equal to 0.05. Here h equal to 0.05, x0 is equal to 0, y0 equal to 1. So by Euler formula, the generally used Euler formula, y1 star will be y0 plus h into f of x0 y0. So now y0 means 1 plus h equal to 0.05, f of x0 y0 means f of xy will be x square plus y. So f of x0 y0 equal to x0 square plus y0. So it will be 1 plus 0.05, x0 square means 0 square plus y0 means 1. It will be 1.05. Similarly, y1, normal y1, the next improved approximation will be y0 plus h by 2 and average of f of x0 y0 plus f of x1 y1 star. So now it will be 1 plus 0.05 divided by 2 into 1 plus 0.05 square plus 1.05, that is 1.051325. So this is the, in this way you can proceed for y2 star, y2, then y3 star similarly. Okay, so this is all about the modified Euler method to solve the ordinary differential equation. But I should make it clear, in both the methods we are having some error, but in case of modified Euler method there is a little bit less error, and in case of generally used Euler method there is some error, there is some more error. Okay, so here you can remember the formula, yn plus 1 is equal to yn plus h by 2 and not h by 2 exactly, h into average of f of x and yn plus f of x n plus 1 yn plus 1. Okay, so not exactly yn plus 1, yn plus 1 star, sorry, by mistake I have left the star, yn plus 1 star, that is divided by 2. Okay, so this is the formula for modified Euler method, and as per our previous discussion, this is the formula for normal Euler method. So this, the topic of discussion was modified Euler method to solve ordinary differential equation. Okay, thank you so much.